Assalamualaikum warahmatullahi wabarakatuh. Memperkenalkan, saya Izas Firsa Aktif NRP 502624194 kelas A. Dan hari ini kita akan mempelajari tentang lab Navigating the Linux File System and Permission Settings. Objectives. In this lab, you will familiarize yourself with Linux file systems. For part 1, we have exploring file systems in Linux. For part 2, we have file permissions. And part 3, we have symbolic links and other special file types. For required sources, we need a server-side protection virtual machine. It's right here. Instructions. Part 1, exploring file systems in Linux. Step 1, access the command line. We will go ahead. Let's use ender one. Wait. There's a new one right here. Step 2. Display the file system currently mounted. To do this, we will first use the lsblk command to display all blocked devices. Is it blocked or blocked? lsblk. Here we go. Every hidden, not blocked file. And now, the output above shows that the CyberOps Workstation VM has 3 block devices installed: SR0, SDA, and SDB. The tree-like output also shows partitions under SDA and SDB. Conventionally, /dev/SDX is used by Linux to represent hard drives, with the trailing number representing the partition number inside that device. Okay, step B. Use the mount command to display more detailed information on the currently mounted file system in the CyberOps workstation virtual machine. Okay. We will now type in mount. Wow, that's a lot of info. Let's spread it out. Okay, we have this familiar information right here, and when we edit, let's search for the highlighted text which says /dev/sdl space on space slash space type space ext4 space dalam kurung rw real-time kurung tutup. I think this means real time. Let's see. Here it is. Right here, we found it. Now, many of the file systems above are out of scope of this course and irrelevant to the lab. Let's focus on the root file system, the file system stored in /dev/sda1. For step C, let's run the mount command again, but this time use the pipe to send the output of mount to grep to filter the output and display the root file system. Let's first use cd/. Okay, now we're in the slash file, and then we can go sl -1. Okay. For our first question, it asks, what is the meaning of the output? Where are the listed files physically stored? And the answer to that is, the first command changes the directory to the directory, which is this. Since we had changed the domain to slash, we get the slash domain. And then we ls -l to show a list. The root directory is the highest level of the file systems because /dev/sda1 is mounted under the root directory or the slash. By listing the files in the root directory, the user is actually listing files physically stored in the root of the /dev/sda1 file system. Okay, let's answer that here. Now, the other question. Why is /dev/sdb1 not shown in the output above? Actually, I don't know. Let's see the answer. Oh, because slash dev slash sdb1 is not currently mounted. Okay. Step 3. Manually mounting and unmounting file system. To do that, let's use the ls negative L command to verify that the directory second drive is in the analyst home directory. Let's first use change domain to the wavy. Let's call it wavy. cd wavy. Okay, it's changed here. Now we use the ls min l. Ls min l. Here we go. There's a space text from way back when. And note that if the directory second drive does not exist, use the make directory second drive second underscore drive command to create it. Here, the command out here. Depending on the state of your VM, your listing will most likely have different files and directories. This is true for most of my videos. Now, use ls minus l again to list the contents of the newly created second drive directory. Let's use this. Let's use the command first without using make directory. ls minus 1 and minus l second drive second underscore drive slash. Wait, oops. Ls mean l second underscore drive slash. Oh, I have 20. Oh, okay. Well, there's I guess my tinkering kind of messed up this step. Let's move on. C. Use the mount command to mount slash dev slash sdb1 on the newly created second drive directory. As use sudo mount slash dev slash sdb wavy slash second underscore drive slash. Sudo mount I was again slash dev slash sdb1 slash dev slash sdb1 and then wavy slash second drive slash wavy slash second underscore drive slash cyber ops mount and yeah. Well, mine gave an output. Oh, it's already mounted. Okay. If it wasn't mounted, it will show no output. Now that slash dev slash sdb1 has been mounted on slash home slash analyst as second drive underscore drive, use ls negative 1 to list the contents of the directory again. Let's see here. ls negative l second drive slash second drive slash. There you go. My file text in there. Yep, the same. Okay, so first question. Why is the directory no longer empty? Where are the listed files physically stored? And the answer to that is, after the mount, slash home slash analyst slash second underscore drive becomes the entry point to the file system physically stored in slash dev slash sdb1. Let's answer that here. Now, we'll go to issue the mount command with no options again to display detailed information about the slash dev slash sdb1 partition. As before, use the grep command to display only the slash dev slash sdx file system. Okay. Mount pipe grep. Let me do it first. I will placing the command mount pipe grep /dev/st. And here we have two files. Unmounting file systems is just as simple. Let's first do sudo. Is this supposed to be sudo unmount or umount? Is it really umount? Okay. Umount. Sudo umount. Wait, unmount. Umount. Sudo umount /dev/sdb1. /dev/sdb1. And let's do a ls-l on second drive. 0. Okay. Let's move on to part 2, file permissions. Now step 1, visualize and change the file permissions. To do that, let's first go to cdlab.support.files/scripts. Copy. Paste. Now put it in. Now we are using scripts. Now let's do ls-1. ls-l. Here you go. A total 64. Now we have two questions here. Consider the sciops.mn file as an example. Who is the owner of the file? How about the group? And the answer to that is the owner is analyst, and the group is also analyst. Now, the other answer. The permissions for sciops.mn are strip ry, strip s, strip rw, strip r, strip r, strip. What does that mean? And the answer to that is, the owner of the file or the analyst user can read and write to the file but not execute it, which is -rw. Members of the analyst group other than the owner can only read the file, which is -r-. No execution or running is allowed. All the other members are not allowed to write or execute that file. Okay, put that here. Now, step C. The touch command is very simple and useful. It allows for the quick creation of an empty text file. Now let's put that in the terminal. Copy. Put that here. Put that here. Oops. Paste. Touch empty as minor file.txt. Wait, what? Oh, it's meant to happen. Why was the file not created? List the permissions or recipe and content of the /mnt directory and explain what happened. With the addition of the strip d option, it lists the permission of the parent directory. Record the answer in lines below. ls/l d/mnt. ls/l d/mnt. Yep. Here's this one says 2018 while this says 2022. A bit different. So well, the answer to that is the permissions of /mnt directory is owned by the root user, but permissions drwxr/strip xr strip x. This way, only the root user is allowed to write to the /mnt folder. Oops. mnt folder. Yeah. Okay. What can be done for the touch command shown above to be successful? And the answer to that is, the command can be executed as root or adding sudo before it, or the permission of the /mnt directory can be modified. Put that here. Okay. Let's try. Actually, no. I think there might need to be some other step before I can do it. The chmod or the chmod. Let's go to the chmod. Command is used to change the permissions or of a file or directory. Let's put the command in the terminal. Copy, and now put it in. Paste. Sudo mount, and yeah, put it in. And now, oh wait, what's this? 1.1 gigabyte volume. Change the second drive directory and list the contents of it. Let's see here. cd wavy second drive slash. Is that right? Oh wait, no. The slash should be right here. Okay. Now we're on the second drive. Now let's do ls1. ls minus l. Okay. It's the same. What are the permissions of the myfile.txt file? And the answer to that is, oh wait. Oh, it's here. We can see it right here. Oh, so that's the permissions area. Let's put it in. Okay. Now use the chmod command to change the permission of my file text. Let's do sudo chmod 665 myfile txt. Why 665? Oops. Paste. Oh, that's different. Hold on. Put it in. Oops. Let's do it again, but this time fixed. Now sudo and done. Okay. It's showed an empty file. Now do ls1. ls another file. Here we can see that it changed. Now it has an X. Oh wait, no. Now it has double RWs. Yes. To this question, which is did the permissions change? And this one's yes. And the answer to the second question, which is what are the permissions of my file.txt, is slash rw slash rw slash r slash x. Let's see. Yep, correct. Yeah. The chmod command takes permission in the octal format. In that way, a breakdown of the 65 is as follows. 6 is octal in is 110 in binary. Assuming expression of the permission of a file can be 1 or 0, 110 means rw strip read as in 1, write as in 1, and execute as in 0. Therefore, the chmod 65 myfile.txt command changes the permission to owner to rw strip, group to rw strip, and owner to r strip x. Now, what command would you change the permissions of myfile.txt to rwx.wx granting any user of the system full access to the file? And the answer to that is sudo chmod 77 myfile.txt. And also, why 777? Because I see why is that. So wait a second. 7 because it's 111 in a binary. So 1 is 1, 1 is 2, and 1 is 4, which equals to 7. Yeah, that's right. Now Now we can move on to step G, which is the chown or the chown command is used to change ownership of a file or directory. Issue the command below to make root the owner of the file myfile.txt. First, we're gonna add in this code to the terminal as sudo paste. Oops, do that. Sudo chown endless myfile.txt. Okay. Now we're gonna use ls-l. ls-l. Okay, it is same. Okay, now that endless is the file owner, try appending the vertex to the end of myfile.txt. Echo test greater than myfile.txt. Echo text test greater than myfile.txt. Okay, now we can check with cat myfile.txt. Okay, there's 3 texts already. I was what's it called again? Tinkering before doing this. So was the action successful? Yes. But how do I explain it? Oh yes. Endless is the user of the file and the permissions are still set to 65 as before. The permissions as they are allow the owner and users in the group to make changes to the file. Let's put that in. Okay. Now let's go to step 2, which is directory and permissions. Similar to the regular files, directories also carry permissions. Both files and directories have 9 bits for the permissions of the owner/user, the group, and others. There are also 3 more bits for special permissions, such as set uid, set git, and sticky, which is beyond the scope of this lab. Firstly, for step A, change back to the home/endless/lab.support.files directory and issue the ls command to list all the files with details. Let's go. Copy. Oh wait, I have to do this or else it'll be weird. Paste and enter. Now we're in a lab.support.files. And now let's do ls-l. ls-l. Here they are. The code. Oh wait, no, not the code. The list. Now let's answer a question. Compare the permissions of the malware directory with the the malware directory or the mininet_services file. What is the difference between beginning part of the malware line and the mininet undertone services line? And the answer to that is there's a mininet. The malware. Oh wait, there is malware. Is there malware here too? Oh my god, there's malware. Malware. It looks all the same, but this one has D. Alright, there's a difference. There's a D right here. And also to answer this question, it's also my answer, which is there is a letter D at the beginning before the permission for the malware directory. Also, the letter D at the beginning of the line indicates that the file type is a directory and not a file. Another difference between file and directory permissions is the execution bit. If a file has its own execution bit turned on, it means it can be executed by the system. Directories are different than files, so the execution bit set. or a file with the execution bit set is and whether a user can enter that directory. What was this of this? The chmod and chown or the chmod or the chown commands work for the directories in the same way they work for the files. Okay, let's move on to part 3, symbolic links and other special file types. We have now seen some of the different file types in Linux. The first character in each file listed with the ls command shows the file type. The 3 different types of files in Linux, including their own subtypes and characters, are this: regular files with strip, including readable files, binary files, image files, and compressed files. Directory files, which is D, which has folders in them. Special files, which include block files, which has a B. Files used to access physical hardware, like mount points to access hard drives. And the other is a character device files, which is C. Files that provide a serial stream of input and output. Pipe files, or P. A file used to pass information where the first bytes in the first bytes out. The first bytes in are the first bytes out. Symbolic link files, which is I. Oh wait, no. It's L. File used to link to other files or directories. And finally, there are socket files, which is S. These are used to pass information from application to application in order to communicate over a network. Now we're going to step 1, which is examine file types. Use the ls strip l command to display the files in the /home/atlas folder. Okay, let's do this. I'm still in last for files. I should probably change that first. How do I do that again? Oh crap. Is it oh wait, I remember. cd wavy. There you go, fixed. Now we're going to ls-l. Okay, here are the file types, files. Produce a listing of the /dev directory. We will use ls -l /dev/ ls / the def v. Okay, wow, that's a lot of yellow text. Oh, that's a lot. Okay, it's a lot. Now, symbolic links in Linux are like shortcuts in Windows. There are 2 types of links in Linux: symbolic links and hard links. The difference between the links and a hard links is that a symbolic link file points to the file name of another file, and a hard link file points to the contents of another file. Create 2 files by using echo. First, let's do this one. Copy, paste, turn, and that one is created. Now let's do chat file1.txt. Chat file1.txt. Symbolic. Let's do echo hard. Wait a second. Do they not need a space? Let's copy first. If it doesn't respond, then we need a space. Okay. Oh yeah, it needs space. Paste again, but this time, oh wait, paste again, but this time we give it a space. Oops, wrong press. Paste hard space there. Now we can do chat file2.txt hard. Wait, what? Oh wait, no, it's right, correct. This is symbolic and this is hard. Now we can use ln/s to create a symbolic link. Default txt and to create a hard link to file2.txt. Let's copy this one first. ln/n copy paste. Wait, what? Oh, this is a space too. Paste file one symbolic. Wait. What's wrong here? Let's try the second one, which is file hard. Paste. Now, file too hard. Wait, what? How did that work? Let's use ls-l to check. ls-l. This space text, file 1, file 2, file text. Oh. I think I just made my own file. If you did it correctly, you should see this version of the command of this one, the symbolic one. Yes. Also notice how the file1 symbolic is a symbolic link with an L at the beginning of the line and a pointer to file1.txt. The file2 hard appears to be a regular file because in fact it is a regular file that happens to point to the same inode on the hard disk drive as file2.txt. In other words, file2 hard points to the same attributes at this block location as file2.txt. The number 2 in the fifth column of the listing for file2 hard and file2.txt indicates that there are two files hard linked to the same inode. For a directory listing, the fifth column indicates the number of directories within the directory including hidden folders. Now we're going to change the names of the original files, file1 text and file2 text, and that's how it affects the link files. Let's do copy, and now put it in. Paste. Also, let's do mv file2.txt file2new.txt. Why not? Dot. Not net.txt. Okay. Now let's cat file1 symbolic. Cat file1 symbolic. No file directory. Let's do a cat file2 hard. Cat file2 hard. Wait, too hard. Notice how file1 symbolic is now a broken symbolic link because the name of the file that is pointed to file1 text has changed. But the hard link file2 hard, still works correctly because it points to the inode of file2 text and not its name, which is now file2 new text. What do you think would happen to file2 hard if you opened a text editor and changed the text in file2 new text? Well, to answer that, we can say that changing the contents of one file will change the contents of the other because they both point to the same inode on the hard disk drive. I would try to say in. Okay? That's all from me. Thank you all for watching. Assalamualaikum warahmatullahi wabarakatuh.